Hello everyone, welcome back to my channel. So till now what we have covered are the access modifiers, and in our previous session we also completed the inheritance topic. So we have started with the OOPS concept. We know what do we mean by OOPS, what are object-oriented programming, correct? And is Java is purely object-oriented or not? We know the answer to this as well. So now, as I promised, that our today's topic will be polymorphism. So we'll learn what is polymorphism, what are the concepts do we have enclosed inside the polymorphism, what is the use of it, how we can achieve it, and in our next session we'll learn about encapsulation and then the abstraction. So in this way we'll be completing the OOPS concept. So let's get started with what is polymorphism. So can you guys give it a try, that what is polymorphism? So polymorphism, so it is a Greek word. So in Greek, poly means many and morph means forms, so which means having many forms, correct? Having many forms. So now the question is, who is the one who have many forms, correct? So the answer to this is, as we are learning object-oriented programming language, so the object is the one who will be having many forms, correct? All right. So what do I mean by many forms? So I'll try to explain polymorphism with an example that you usually get on Google, the animal example, correct? Because the reason that why I am taking the already taken example that we get in Google is the reason that polymorphism sometimes gets confusing. So at times, even after a week or two, you will get confused that what is polymorphism. So we will Google it. Definitely we Google, correct? So we Google it and we see such kind of examples, and at that time we might not be able to recall the concepts. So if I take this example, it might be easier for you all to understand it in a better way. Even when you get confused, you can just refer Google as well. But I believe that you should not get confused after this session. So let's get started with this. So let's say I'm having a class animal. So this is our parent class, and I'm having class animal. Cat is also an animal. Class dog is also an animal, capital D. Class tiger is also an animal, correct? Do you know that all the basic criteria, all the basic feature of animal will be applicable to all this? So what we can do is we can perform extend, or I can say we can perform inheritance. Extends animal, correct? So in this way I can inherit the animal class. All right, so we are inheriting the animal class. So now, as I have said that, just keep this thing aside for now. As you all know that, let's say byte b is equals to 1. Can I say int a equals to b? The answer to this is definitely yes. Why? Because b is smaller than this. We have implicit typecasting, correct? So the same way, what we can have over here is animal is greater among them because it is the parent of cat, dog and tiger, correct? So I can assign cat to animal. So I'm creating an object on, yes, like this. I can do this. Yes, we'll see what are the different ways, like what is the use of it and what are the restrictions and limitations and how this works actually. What is the difference between cat, c is equals to new cat, and cat like this. All right, so we'll see that one as well. do not worry about this. So I hope it is clear to everyone that yes, we can give the parent size over here and we can call the child constructor, correct? Yes. So I hope it is clear to everyone till now. So do you have any doubts till now? You can ask me, or we'll proceed further and we'll see how we can use polymorphism, or what is the actual concept behind the polymorphism. So you know that yes, we can cast animal like this. So this is something called as upcasting. All right. So now, yes. So polymorphism, the main concept of polymorphism is method overriding. So what is method overloading? What is method overloading? It happens within the same class, correct? Same method name, different parameter list. This is the only requirement, correct? Yes. So try and recall the concept of method overloading that we had already covered till now. So I hope you are not getting confused with the concept of method overloading till now. Means I believe that you have a better grip on method overloading concepts. So do you have any doubts on the previous stuff that we have already covered? I believe you should not. Alright, so now what we are going to learn is method overriding. So method overriding is a concept of polymorphism which says that if I have a method in my parent class, let's say eat, okay, or let's say run, example this is correct. I am having a run method over here. It is having some functionality in my parent. So my child is extending my parent, correct? My child is extending parent. So now child inherits the property run, correct? That's definitely true. So what if there is a need of modification for this particular function? Let me relate it with a real-time example. So let's say BMW is a class. It has a method void run. All right. It prints system.out.println running at 80 miles per hour. All right. But now the BMW has created a new car M8, and you know that it is developed by BMW, so it will be definitely extending BMW because it will be having the all the basic feature of BMW. But now what's the new thing? What's the special thing about M8 version, M8 car, is that the M8 car is not running at 80 because it is running at 120 miles per hour. Now the question is, if I create its object like M8 M is equals to new M8, or we have also seen the other alternative as well, like the parent first M2 equals to new M8. We have seen both of them, and now if we see M dot run or M2 dot run, where it will land? It will land over here. Am I right? Yes, because M8 is not having any run function. It is inheriting the run function from its parent. But now I want to modify. I want some modification because I know that it will be running at 120 miles per hour. So what we can do is we can create a same function because the way we are calling is the same. We don't want to change its functionality because it is also run. It is also running. It is also running. It's just a modification of our previous feature. So what we do is we write the same method, the same parameter, plus the compatible return type. So for void, the only compatible is void, correct? we'll see what do we mean by compatible, and I believe that you all already know about that. Over here I can say system.out.println running at 120 miles per hour. So now what's happened, can you guess? We have changed the run, this feature, the run feature for this particular class. We have modified it, though it was extending the BMW class, though it was like inheriting the property of our BMW class, but we have modified this functionality for this particular class, not for all, but for only for this particular class. Correct? So let's give it a try and then we'll try to explore more. So let me go back to our objects. All right, oops. So we had a BMW car. All right, so we have a run method already over here. Let me delete this. We don't want main method over here. We will be running the child class, correct? Yes. So I can say that running at 80 miles per hour, correct? Now M8 is the one who is extending this car, BMW, correct? All right, what I can do is M8 m dot run. What will happen? Let me run this. See, can you see the output over here? It says that running at 80 miles per hour because M8 is not having any run method. It is inheriting the run method from its parent, correct? So the run method is declared in its parent, that is in the BMW class. Great. Now as I said, we want some modification there. This is its special feature. All right, so what we can do is public void the same name as run, and I can say system.out.println running at 120 miles per hour. Now if I run this, can you see what is the output? Now it comes out to be this. Now if I create the object of like this, so let's say we have BMW M2 is equals to new M8. Now if I say M2 dot run, then to what will be the output now? Then to it is still the same, because though it is M2, we are invoking its constructor and it is just the type of it, so it will be working for this particular class. As I said, the constructor I will just give you a short way to remember all this thing. So the constructor to whom we are invoking or to whom we are pointing out is the one whose instance stuff we are calling. Do not worry, we'll see what do we mean by static binding, dynamic binding for now, but yes, it is clear that we have modified a feature. Am I right? All right, so what if I have something like this? It is just a easy question, but now you are learning polymorphism. This might got have confused you. So this what constructor we are calling? BMW. So will this run work or the BMW run? Let's see. And now you would have already guessed. If you have guessed, just write your answer in the comment section. WB is equals to new BMW, and now if I say b dot run, can you see the output? It says that 80 miles per hour. So now the reason is, you have already known to this reason that we are invoking this constructor for now. It will point to this particular. This is not the official thing that we can explain to anyone, but I am just giving a short way to understand this thing so that you don't make mistakes. Right, over here this object is purely based on my BMW class, so it will be pointing to that BMW class. Over here I'm just upcasting it, sorry, over here the first example is also purely based on the emit class, correct? So it is again pointing to this run method of the emit. But now for the next example, as I said that int can store byte values, correct? Because byte is smaller. But then to whose value we are storing? The bytes value, which means this will again point to this run. Is it clear to everyone till now? All right. So we know that what do we mean by polymorphism for now, because one object, see this BMW object is having, I can write BMW, this is my type of object, correct? B is equals to new BMW. I can write this in this way. The second way that we have saw is BMW C is equals to new M8, because M8 is its child. So we have two ways. So let's say M7 is also extending BMW. Then how can I write that? BMW, I also get the ease of writing it like this. If 10 more classes can inherit it, or if 10 more classes are inheriting the BMW class, then I have 10 other options as well. So which means the type of my object is same, but it is having different forms over here, correct? M8 is a BMW car, M7 is a BMW car, M4 is again a BMW car, correct? So my one object is having many forms. Over here we have 3 forms, which means we are having polyforms, correct? Which means polymorphism, one object having many forms. So I hope you understand what do we mean by polymorphism. So over here, if I say BMW B is equals to new BMW, all right, this is having the form of BMW, which means this will be invoking all the features of only the BMW class. If I say BMW B is equals to new M8, this will invoke the feature of M8 class, and M8 is indeed referencing, or I can say the inheriting BMW. So M8 is also having the BMW features, but this will provide us the modification as well, because M8 has done some modification to its features, correct? So if you have understood this, please type yes in the chat box so that I understand that you have got this concept till now. Okay, so now let's see what are the rules. Like for method overloading as well, we had some rules, correct? So for method overriding, what are the rules? What are the rules for performing method overriding? So if my parent and in the child class, this is how method overriding happens. The parent's feature is inherited by child and child is modifying it. This is something called as polymorphism, or I can say that method overriding, correct? Yes. So now let's say this is having some method name, correct? We are method overriding, we are doing method overriding. So at both the place the method name should be same, correct? Same. Okay, I'll just make it like this. Now what do we mean parameters? It will have some parameters. So it should also have the parameters or the same parameter list. Okay, same parameter list, and you know the types that are compatible. So you know the compatibility. Now the return type, if you have some return type in the parent, same or compatible, I can say same or compatible return type. Okay, yes. So for example, over here I'm having double return type, and over here I'm saying void. Is it compatible? Compatible with double? No, which means we'll get an error. Correct? We'll get a compiler error, incompatible return type. Correct? Yes. So this is not a valid example for method overriding. Clear? Yes. Now one thing that is remaining, we have covered the return type, the method name, the parameter. The one thing that is remaining is the access modifier. Correct? So over here, if we have some access specifier, it should be, or I can say it can't be less accessible. So let's say over here I am having public. So over here, if I say private is less accessible than public, which means we'll get an error, which means it is not a valid example for overriding. So I hope you have noted this down and you will be practicing this and trying to break all the concept that we have covered till now, so that you get the better exposure to the error ways as well. So I hope it is clear to everyone. Do you have any doubts? All right. Yes. So I believe you don't have any doubts till now. So this is the concept of method overriding till now. You know what is method overriding, what is the need of it. So what is the need of it? Modification, the main need. Modification. Correct? You know polymorphism, and we can say that it is the only important concept of polymorphism. So method overriding is a concept of polymorphism, so don't get confused. And polymorphism, you know that one object, many forms. Like BMW can be, the type BMW can be assigned to the object of M8, M4, M7 or any of the child class of BMW. Correct? All right. So now let's see, what do I mean by static and dynamic binding. So now we are going to see what is binding, method binding. Okay, so there are two types of binding, the static binding and dynamic binding. Sorry. Yes. So like this. So what do I mean by binding? What do I mean by method binding? Correct? So method binding, just keep the heading over here. Method binding means binding a method call to method declaration and its implementation. Again, not at all clear. No worries. So we'll see what happens if you have static int a. At what time it is binded, or to whom it is binded? It is binded to the class. Correct? At what time? At compile time. If you have just int a, at what time it will be binded? At the time of object creation. Correct? Or I can say to the object it will be binded, to a particular object. So at what time it is, at what time does the object gets created? At the runtime. Correct? So this is something you can relate like bindings. All right. So the same way, what do you mean by static? The compile time. And what do you mean by dynamic? The runtime. So when the method invocation or the method call that are binded at the compile time are static binding, is known as static binding. Or when the runtime, means when the method is binded at the runtime, is called as dynamic binding. And you know, you would have already guessed by seeing these two words. Now we'll see what do I mean by this, but now we'll just go through the keywords. So static binding, we can also say at compile time binding, we can also say at early binding. So don't get confused with any of these three words. They are used interchangeably, so do not get confused. This is, you would have already guessed, dynamic binding, runtime binding, and late binding. Okay. Yes. Great. So now we'll see. So if I make a method static method and instance method like this, so which of them are more likely to get binded at the compile time? Definitely the static one, because we are using the static keyword, which means only one copy and is binded to the class, so there is no need of object creation, which means at the compile time. Correct? All right. And the instance method at the dynamic time or at the runtime, we can say. Yes, that's great. So now let us move back to our yes over here. This is a kind of method. Which kind of method is this? Instance of static? It is a kind of instance method, correct? So it is getting binded at the runtime, correct? So now what if I make this static over here in my parent class? Yes, see, can you see we get an error over here? And can you guess the error? The instance method cannot override the static methods. So one thing that you have to note down is static methods. Just note down this in bold. Okay, static method cannot be overridden. Now the question is why? Correct, we'll see why. But yes, static method cannot be overridden. We are getting an error over here. Great. So we have covered till now that static methods cannot be overridden. We'll see why. Okay, so now let's see. Yes, we get the error like this. So now can you see at what time? Yes, so if you are invoking a class, if you are creating any method or any objects like this, you are invoking it at the dynamic memory allocation time, or I can say at the runtime. But what happens over here in our BMW class, this run method is static, correct? And as I said that, let's say student s is equals to new student, correct? Now this will give you a better idea. As I said, break this into two parts. This at the compile time, we have already covered this, and this happens at the runtime. Am I right? Till now, do you have any errors? No. So as I said, it might be confusing for you all. So let's say this and this means the BMW and the M8 class. So M8 extends BMW. If I try to say M8, M is equals to new M8, no worries. If I say BMW M is equals to new M8, what happens over here? This happens compile time, this happens at the runtime. So what I am trying to explain you, this run is getting binded to this class at the compile time. This gets binded, which means this run method is already available at the compile time itself, and it is binded to BMW, or I can say that it is binded to M for now, because this run method is available and you know that there will be only one copy. So why to wait for the runtime? Why not allocate it at the compile time itself? So which means we are binding run to M over here at the compile time. So let's say if we are able to override this, okay, so override overriding will happen at the runtime. Correct? As I said that the later part, the child class part will be happening at the runtime. So over here, what will happen? My child class will again try to create a method run. But now what will happen? There will be a conflict which says that M is already having its static method run. M is already having run. Then why you are creating it again? If you are trying to create it again, it is a duplicate method and I won't allow this. Which means we cannot override the static method. Yes, correct? Yeah. So previously when it was instance, what happened over here? Let me explain you this. What happened over here is there anything at the compile time? Any method binded to M? No. So M is not binded with any method. Now at the runtime, what happens? It is an instance method, correct? So runtime instance method are this, but this one comes from parent and this one comes from child. So now I'll just give you a trick to remember that whose method will be binded to M8 at the runtime. So the example, you know, the local variable example, when someone asks your phone number, now you will definitely give your phone number, correct? But when you were young or when you were kid, if someone asks you that please give any mobile number, so you used to give your parent mobile number because you didn't have any. But now once you have your own mobile number, you always give your own mobile number to that person, correct? So over here, does M8 has its own run method? Definitely yes. So this run method will be binded to M8, which means it will give us running at 120 miles per hour because it is having its own child method. Why to bind with my parent? Correct? Because the reason that why it is binded, yes, this is the logical reason that we have understood, but also the need for this is the child method will always be modified for that particular child and we need the modified method for that particular object. So is it clear to everyone till now? The dynamic and static memory allocation for now, or I can say the dynamic and static binding. Is it clear to everyone? Yes. So now, great. Yes. So over here, if I don't make this, then will we get any error? No, because it might get overridden by my M8 class. If my M8 class don't have any run method, will we get any error? No. Let me try this. If I just comment this out over here, now if I say m dot run, correct, and yes, if I say m2 dot run, we get the parent class overridden or like the parent class features, correct? But now as soon as I remove this static and I make this available, which means I am overriding it, correct? So it will give us an output as running at 120 miles per hour, correct? So now what if I make it a static and what if I make it this one as static as well? Will it work? It does. Now can you guess the output for this? All right, let me run this and then we'll debug this. Okay, now can you see the output? The output comes out to be running at 120 miles per hour for this object, the first object. So what I am trying to do is this will happen. Compile time. Is there any static stuff that needs to get binded with M? Yes, there is. So this run method need to get binded with M. And whose static stuff we are checking? We are checking the static stuff of this particular class. So M8's run method will get bind to M at the compile time itself, and at the runtime nothing will get, correct? Because as I said, if something gets binded at the runtime, at the compile time, it cannot be overridden, correct? So now let me do this m2 dot run, and now let me run this. Can you see it says that running at 80 miles, but over here we have running at 120 miles. So now it might be easy for you all to understand what happens over here. At the compile time, is there any stuff from the BMW class that need to get binded at the compile time to M2? Yes, a BMW class have a static method, correct, that needs to get binded to M2 at the compile time itself. So this run method will get binded to M2, and at the runtime nothing will get binded to it, or nothing will get overridden, because we are just having one feature over here, correct? So that's the reason why we get running at 80 miles over here, because for M2 this method is getting overridden, or sorry, binded to this particular object. While in our prior example, when we were having like this, when we did this m dot run, what happened? It will check at the compile time, is there anything of this class that needs to get binded to M at the compile time? So it won't check the BMW class, because we are not at all pointing to the BMW class over here. We are pointing to the M8 class over here. So it will go to its own class first. So it will give preference to its own class, and it will be doing this. And if I don't have run method over here, then it will be definitely binding the BMW's run method to it, because it is also static at that time. So I hope dynamic and static binding is very much clear to every one of you. So do you have any doubts? You can ask me. All right. So now few thing about method overriding is as well, you know, static method cannot be overridden, correct? Now my question is, can I override a private method? The answer to this is no. Let's try this. Let's make this private. Yes, and let me make it static as well, so that we perform the actual overriding. Yes. So now can you see, do we get any error? No, correct? Now if I say m2 dot run, do we have run method like this over here? No. Now what happens over here is, run method of m2 for this particular class is private, and as I said, private cannot be accessible, is not accessible outside its class. Let it be its child class, or let it be anything else, because as I said, private context is only accessible to its particular class, correct? So let it be its child class or grandchild class, that doesn't matter, we'll get an error like this, correct? And what error do we get? The method run from the type BMW is not accessible, correct? So now if you are getting doubts like whose method this will call or something like this, so now let me tell you. Now your question will be like, run is over here, then why it is not binding it to this? Now the answer to this, BMW m2 is equals to new BMW. We are trying to point m2 dot run. BMW class is having run, but it is not visible at this place, correct? So that's the reason why it is not binding to its, sorry, over here it is M8, it is not binding to the M8's run, because there is run in the BMW as well, but I cannot bind it to, or it is not accessible for M2, because M2 doesn't lie at this, or doesn't lie in the BMW class. So do not get confused with all this kind of stuff. And over here it is not a overriding, I am just declaring another method for this particular class. All right, like previously when we were having static at both the places, we didn't get any error, because the thing is we had run method at both the place, but both of them were different. Okay, they were not, this method was not overriding this because it was different. It was a static, and static method cannot be overwritten. And if something that cannot be overwritten like this, which means it is an independent method, and it is an independent method. So don't get confused with these concepts. I know it is a kind of confusing context, but I hope it makes a clear sense now. So can I override a final method? You know, final means the thing that never gonna change, correct? So if something that will never change is there, so is it any sense of overriding it? Because I know that this thing won't get changed. So is there any sense of overriding? Because the main use of overriding is modification, and I know that final stuff cannot be modified. So again, final methods cannot be overridden. So let me make the BMW class final. I'll make it a public back like this. Now this, can you see we get an error? What error do we get? Cannot override the final method. If I declare final over here, will it work? No, again it doesn't work, correct? So I hope it is clear, because there is no sense of giving you the access of overriding the final methods, because if you were able to override the final method, which means you are able to modify it, and modification is not something that can happen in the final context, correct? So I hope it is clear so far. So yes, just note few things on the top, that static, private and final methods cannot be overridden. Yes, so this is a very important point. You might get confused if you don't know this. If you know this, you can just easily give answer to any of such codes, because you know that static, private and final is the one that never going to get overridden. Yes, so you are asking that what is binding? We have already covered even in this session as well. You can just go back. All right, but then too, I'll just summarize what we have studied. What was binding? Binding, a method called to the declaration, or I can say that to its declaration and its implementation. And we have seen that the left hand side, the shortcut that we saw, correct? So like for this student s, some things were getting binded at the compile time, the left hand side, and the right hand side at the runtime, because at this moment the objects were created, correct? So static stuff will always get binded to the class, or I can say that to this at the compile time, and the instance stuff will get binded at the runtime to the objects. So it is dynamic binding. So I hope it is clear to everyone. Yes, so we have completed the polymorphism topic of one object having many forms, correct? And we have saw our own example as well, the car example, correct? And also we have seen how polymorphism is achieved, what is method overriding, what is dynamic and static binding in method overriding. And if you want, I can just relate it with the example that you get on Google. So they have animal class, they have eat method, and they say system.out.println eating, correct? Now they have several classes for their particular animal. So let's say the dog extends animal, the cat extends animal. So in dog as well they have eat method, and in cat as well they have eat method, because they want to modify the eat feature. Okay, and in dog they say that eating, you can say bread, they have bread as only, I guess. Yes, and in cat they have eating rat. So this over here, both of the classes are overriding this eat functionality for their own class, and they are modifying it with that particular features. So now you can definitely relate to this kind of examples, correct? Yes. So do you have any doubts till now? If you have any doubts, you can ask me, or we'll just end up today's session and we'll meet tomorrow at the same time, that is 7:30, and we'll see what do I mean by encapsulation, and then we'll cover what is abstraction and how it can be achieved. I hope it is clear to everyone so far what we have covered. So inheritance and polymorphism is completed. Just 2 more steps to complete the OOPS concept completely. So I believe it's clear to every one of you. So if you have any doubts, you can ask me in the comment section, and thank you.